All right, part 3, we're on number 8. A rock on Mars. Draw it. A rock on Mars where the gravitational constant is 8.8 meters per second squared. That's what happens at Mars. What color is Mars?
Rock on Mars.
Red.
Red, so we're still into the Christmas theme. Here's Mars.
It's like a rock on Mars.
The gravitational constant on Mars, like ours is 9.8. Theirs is 8.8 meters per second squared. A rock on Mars, so draw a rock. We'll have a green rock on a red planet, keeping with the theme. Alright, the rock on Mars, it weighs 245 pounds.
That's a big rock.
What does it weigh on Earth? Remember we used to do a lot of these? It's been a while. What does it weigh on Earth?
Forget how to do these.
Yeah.
I'll give you the first step. Maybe that'll jog your memory. Change it to mass. Change it to mass, because mass on Mars is the same as mass on
easy.
Earth. Then go back to pounds on Earth. How do you change it to mass? Weight equals mg. Weight equals mg. Weight equals mg.
Hold on.
I'm going to begin changing it to mass. So you can ignore me or join me for this part. On Mars, I can find the mass. Weight equals mg. The mass of the rock is the same on both places. So the mass of you is the same on both places. The mass of all these decorations, if they were on Mars, poor things, it would be the same. So weight equals mg. We have the weight, 245 on Mars, equals the mass is what I'm looking for, times their gravitational constant. So 245 divided by 8.8 will get me the mass on Mars. When I divide it, I guess I did sig figs in the middle, but if I kept it, is it 27.94, 84?
27.8.
74? 27.74?
27.8 or
84.
you were close though. Just one off.
Alright, I thought that's what I said. Alright, so that's where the mass of this rock, mass is how much stuff there is. It's the same amount of stuff here.
Wait, I got
So,
a question.
yeah, that's not the answer.
Nah, yeah, no. But for converting weight from
Mass.
Earth to mass from Earth to Mars, it's always gonna be 8.8.
No, we would use 9.8 on if we're
On our,
Well, for on Earth.
We use 8.8.
Oh, okay,
If
but
we're
from
on-
Mars to Earth is 9.8.
yeah. Now Mars, if you're on Mars, you use Mars's number. If you're on Earth, you use Earth's number. So I had to give you that. I told you G on Mars is
Oh, yeah,
8.8 meters per second squared.
Okay, yeah, I get it now.
Alright, I won't give you it on Earth, but any other planet I will give you it. Yeah.
Is that actually true? Is that actually what the weight is? I
What,
mean,
yeah, you want to keep going now?
no, I was asking, is that actually what the gravity is?
Yeah, that's
Yeah.
that's
Move
not
Saturn,
the
it's like
weight.
we're still in
This is still mass. So now how do I go back to
No, I was
this?
asking I was asking if that was actually the gravity of Mars.
Oh, yes it is. I'm sorry, I misunderstood. Okay. So, we're gonna finish now, so beat me to the punch. Now we're back on Earth, where mass is now known, because it's the same on Mars. So we get weight equals 27.84 times 9.8. I will allow you to call it positive or negative in this case. Weight is downward. 9.8 is generally used with a negative number, except when it's in the form of course normal. So if you put positive, I'll give it to you. If we put negative, because normally when I say how much you weigh, you don't say negative 140. You know, so you normally use, it actually is negative, but we usually don't call it that. What is that number? I don't think I have it right.
Is it 270 pounds?
Two. Wait. Yeah. Well.
What is it?
Yeah.
270 what?
270.
Alright, well what was it before that?
Oh, 272.84.
272, notice, it has to be, we dropped the final 272, we dropped the 2 because of 2 sig figs. The 2 will not raise the 7, it stays there. So that is, since we started in, what were we using in this problem? We were in meters per second squared. So what unit, class, what unit? We are in meters per second squared, remember? So it's newtons, alright. So 207, if you're using the Squashy Man, we'll tell you that if you're working in meters, that tells you you're in metric system, and newtons is a metric unit, pounds is what they call an English or American unit. So 270. Did you get 270?
Yep.
Did you get 270 newtons?
I mean,
Alright,
I
newtons. 05.
I was staying in.
05.
05.
I was staying in English. I was staying in pounds, and I got the same number.
How did you stay in pounds? You didn't know this in feet per second squared.
Oh.
So you can't go to pounds in that one.
So you have to convert 245 originally.
Yeah, the only way we could get to pounds is to start here and convert that to feet per second squared, which no one feels like doing. Alright, I don't know how many feet are in a meter anyway.
Because see, when I multiplied 245 by I divided 245 by 8.8.
Just buy a bottle of water. There's a grocery store right there.
It's
It's like,
27.84
give me a
kilograms.
bottle of water.
And then multiplied that by 9.8.
Alright, so you divided this by, so weight equals mg, and you divided it by
G.
8.8.
And then that resulting
Wait a
mass.
minute, we have a problem here. We have a problem.
Yeah, but it's still.
The thing doesn't match.
Oh,
Yeah,
wow.
Yeah,
245
as
pounds
Brian
doesn't
is
match with
trying to
meters per
patiently
second.
Sounds
point
like a
out,
match.
what's the disconnect here? See, I
Pounds
started.
don't match the
right.
gravity
Wait, the
meters.
original weight was.
Yeah, so let's go, can we just call this newtons and be done with it then?
Yes.
Alright,
245.
so I won't count the units
Hold
on
on.
this problem because they were messed up.
Oh.
Alright, so the number will still be the same. So we have to match meters per seconds with newtons, and I had pounds. So I had given you the 8.8 in meters per second
Did they
squared.
just
They
watch
did not
you?
match. So we ended up with 280, and I'll take either unit because I had it in there wrong. It should be 270. It was 270 when we round it.
Yeah.
270 newtons.
Okay.
All right. All right, number 9. Okay. Draw a book on a platform, like a table. Draw a book on a table. Here's a book on a table. Use of S for this book is 0.21. Use of S is 0.21. Use of K is going to be 0.15. All right, tell me why is the static friction coefficient greater than the kinetic friction? So it's in words. Why, I'll put it in symbols. Why is mu sub S greater than mu sub K?
Why is because God made it that way?
Yeah. The end.
Answers.
How many we got here?
18.1. It's greater than
We're at 9 already.
It's good
Is this the third part?
2021.
Yeah, we have a lot of pauses, that's why.
Solid. Solid answer there.
I'm gonna look up something.
Well, Christmas is actually not next week, but maybe the week after that.
Yeah. We
but it's still 55 degrees outside, so.
It's 32. Alex, you know, it's technically still fall.
Technically, snow.
Okay, if
It's
you
still
define your
fall. It's
senior
not
It
snow,
never
it's
snows.
frost.
Technically, it needs to snow before it's actually Christmas.
Technically, it's already
Okay,
snowing
then
again.
does it
Alright, I'm
need
still
to-
waiting.
Does it
Okay.
need to be warm before
I'll wait
it's
for you. I'll wait for you.
All right, contemplate quietly. Contemplate the answer quietly. Greater than. All right. So you're writing out in words why mu sub s is greater than mu sub k.
Oh, I should probably.
Interesting. Okay. All right, let's look at it, a picture of it. Recall what's happening on the atomic level. Here's looks like a smooth table, but really the surface looks like that. And where'd my red go? The book, it looks like a smooth surface, but it's really like this. So there's all this interlocking and rubbing and snagging and so forth. So now take it from there. Why is mu sub k going to be less than mu sub s? Could you explain it, Emily 3?
Because Newton's first law, that an object at rest wants to stay at rest, so when you're trying to push it, it doesn't want to move.
So what is actually on the atomic level? Why then is it taking more? This is less. Why is there less interlocking and so forth? Why is there less interlocking when it's in motion than when it's not? Can you kind of explain that? It's sort of like, remember that day we had the guys push this table? Once they got it started, it was easier to keep it moving. And that is, can someone else explain why
It
this?
just doesn't have time to settle in.
Right, right. So once you unlock this and you get it moving, that's when you used your mu sub s for still. Once it's moving, then all that interlocking it's still snagging, but not as much. You've got it going. So that's what you have to put in some coherent explanation tomorrow to me. So. Have you noticed that mu sub k and mu sub s are decimals a lot of the time, like 0.23, like 0.15, 0.21? Can they be greater than 1?
I hope so.
Can they be
Because
greater than
God.
1? You got some greater than 1 in left. I looked it up. A value of 1 means the frictional force is equal to the normal force. Some people think that the coefficient of friction can never be more than 1, but this is not true. A coefficient of friction that is more than 1 just means that the friction is stronger than the normal force.
Do you need this too? I didn't give this to you.
Oh yes, you do. How about you? You too.
I already turned mine in.
With this?
Yeah.
Okay. Alright.
Oh wait, the lab?
It's not due today. It's not due till Wednesday, but some people wanted to hand it in early.
Can I hand it in?
Yes. Alright.
Wait, what do we
If
tell
you
these
got an explanation similar to what I said, if you could explain why mu sub s is greater than mu sub k, cross out 04. Lots of O's.
What's the time, Miss Powell? Like how much time?
Alright, yeah, we could stop it. Have one more little segment. We don't have much left.